just to be sure it is started. Okay, starting broadcast right now. Ready?
Yeah, go ahead.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to DBA Fundamentals Virtual Chapter Meeting for April. Today's presentation is entitled Building Perfect SQL Servers Every Time. It was otherwise known as You've installed SQL Server and now what do you do? But we thought this might be a better title. It will be presented by Joey D'Antoni, and I'll be turning things over to Joey in a minute, but first I'm going to bring a few things to your attention. I would like to thank PASS, Professional Association of SQL Server, for supporting our chapter. The management at PASS really worked hard to bring free training to everybody all over the world. The free training the SQL community has is amazing. You wouldn't believe it's coming from an outsider how great it is. My name is Steve Cantrell, and I'm the Chapter Co-Vice President of the DBA Fundamentals Virtual Chapter. You can send any of us questions. Our contact information is on our website, fundamentals.sqlpass.org, on the About Us tab. On May 6th, we're going to have a presentation with Ayman El Ghazali. He'll be presenting a session called SQL Server Internals Party, Storage, Memory, and the Query Lifecycle. You really won't want to miss that. Okay, that's all the housekeeping I can think of for the moment, so let's get started. Today, Joey D'Antoni will be presenting Building Perfect SQL Servers Every Time. Joey is an architect with over a decade of experience working in both Fortune 500 and smaller firms. He's currently the solutions architect for SQL Server and Big Data for Anexanet in Pennsylvania. They're a Microsoft Gold Partner consulting firm. He's a frequent speaker at events such as PASS Summit and TechEd. I'm going to turn it over to Joey now. Joey, there you go.
Thanks, Steve. Hi, everyone. I'm Joey D'Antoni. This is Building Perfect SQL Servers Every Time. And this is a session that I came to writing. So I'm a consultant nowadays, and I get to see a lot of SQL servers. And I do a lot of health checks on SQL servers. And I see a lot of really poor practices based on implementation of those SQL servers, and that they can lead to really bad performance down the road. It's kind of a critical thing. It's kind of a critical thing in terms of how SQL Server works and how it keeps functioning in the future, more importantly. So we're going to talk today a little bit about some of the things involved with that. Like Steve mentioned, I'm a frequent speaker on database administration, big data, and career management. I'm the co-president of the Philadelphia SQL Server Users Group. For any of you who are in our area, our SQL Saturday is going to be on June 7th. It's SQL Saturday 294. We're actually still accepting speakers, so if you want to submit a session, feel free. I'm a Microsoft Certified Solutions Expert for Business Intelligence, but don't let that fool you. I used to be a DBA for a long, long time, and I still know how to do it. If you go to joedantoni.wordpress.com, I'll blog. It's my blog, and I'll have these slides up. And I'm J D'Anton on Twitter, Facebook Joey D'Antoni, and LinkedIn. This is not the right URL for the slides from this presentation. I didn't edit that. Sorry, guys. If you want to know anything about column store indexes, that's there. So let's talk about the SQL Server default installation. There's not a lot of positives I have to say about it, except that it works. It's not by no means is it considered the best practices for SQL Server, and we're going to walk through a lot of those things you need to fix. Then we're going to talk a little bit about the importance of standards. Standards are really important. So I've worked in a wide variety of shops. I have pretty small clients. I also have some really large companies in my background. I used to work for a large cable company on the East Coast. They've basically just acquired the world in recent times. You can probably guess who they are, or you can find out for real if you looked at my LinkedIn profile. There I managed on the order of about 1,000 SQL servers. It becomes really difficult to manage that many servers if everything's not built exactly the same. So we're going to talk a little bit about that, things you need to consider standardizing. Then we're going to talk about automating the process. So, sitting there and clicking next when doing a SQL Server install isn't the most productive thing you can do as a DBA. Actually, I'd say it's one of the least value-added things you can do as a DBA. Your time's far better spent, doing query tuning or proactively working with the business to help improve their applications. So we're going to talk about how to automate the process, and actually we're going to lead off in a second with a demo on that. Then we're going to talk about building a private cloud. So when I was at that large cable company, one of the things we did was we built our own private cloud solution. If any of you have used Microsoft Windows Azure, or excuse me, Microsoft Azure, the name changed last week for those of you who don't know, you can quickly get a VM running SQL Server in about 6 minutes. We did the same thing, except we did it internal to our business. We had a web interface where users could come and request a VM. It would have SQL Server, or would just have Windows, or would have any other operating system that was in our menu. It was an interesting process. It was quite challenging, but we learned a lot, and I'm going to share some of that with you. But first, we're going to go look at a Windows server. And I really wanted to install SQL Server 2014, which just came out today. Moments ago, it made it to MSDN. My download didn't finish in time, so we're still installing 2014, but we're gonna install the CTP version. So here we're going to run this batch file called standalone SQL install.bat. I'm going to let this kick off just to make sure everything's going right before I start going back into slides. If you haven't seen this is going to be a silent install of SQL Server. And when we're done, it's going to be fully configured. So let's pop back to the slide deck. So I kind of wanted to call this presentation "Just Don't Weeping Click Next," but I decided this was the better part. The discretion was the better part of valor, and I chose a little more politically correct title. But I really feel this way. If you just click next through your SQL install, you'll end up with everything installed on your C drive. Your max memory won't be configured. You won't have any sort of best practices. And we're going to run through some of these best practices and where they impact your SQL Server. A lot of these things are maintenance. A lot of these things are performance. So you're going to impact your server's performance, the way everything behaves, and your ongoing support. So whatever you do, don't just click next. If you take one thing out of this presentation, it's to think a little bit more about your SQL Server installs. So the first thing I like to talk about is setting max memory. The default setting for max server memory in SQL Server is 2.1 petabytes. This isn't all the memory that the SQL Server processes are going to use. There is some memory that's external to SQL Server, but this is just for max server memory. If the setting's not set, SQL Server is going to go out and try to grab all the memory in the box. And what this can do is lead to paging on the of the Windows OS. So much like SQL Server will spill to TempDB in slow operations, if Windows doesn't have enough physical memory to maintain all of its pages, it will spill to the page file on the C drive or the D drive. And in turn, you're going to be doing operations on disk that you should have otherwise been doing in memory. One of the first rules we learn as DBAs is that memory is always faster than disk. The best practice for this, especially when we're talking about single instance servers, is to allocate 80% of the physical memory on the server to SQL Server. The one exception to this is if you're building really large memory servers, so if you're working with servers that have 500 gig or a terabyte, then you really only need to allocate 6 to 8 gig to run Windows comfortably. Generally speaking, the minimum memory option doesn't need to be set. There are a couple of other exceptions to this, or things you need to think about. And what I'll share after is a script that will automatically set this based on your OS memory. But But there are a couple of other things you need to think about. If you are working with a multi-instance server, this is the total of all the memory on the server. So if you have 2 instances and you have 12 gig of memory on your server, you really only want to allocate 9 gig to total, so maybe 4.5 gig to each of those instances of SQL Server. It's just something to think about, and where it tends to get a little bit messy is in cluster environments, but we're not going to talk about that necessarily today. The one other tip I'll mention here is if you're using virtual machines, you may want to talk to your VM administrator about reserving that memory as well from the VMware side, but that's a little bit out of scope for today. So max degree of parallelism. What max degree of parallelism is the query optimizer in SQL Server will spin parallel threads to the available processors in query execution. The default setting is 0, which is unlimited. So SQL Server will try to use all the available processors. This isn't a good practice. This can lead to CX packet and scheduler waits. And here are the best practices, and this is from Microsoft. For servers with greater than 8 CPUs, we want to set the MaxDOP to 8. For servers with less than 8 CPUs, you want to set MaxDOP from 0 to n, where n equals number of CPUs to NUMA node. If you're not familiar with NUMA, it's the way your motherboard on a server is logically separated. There's memory tied to a specific CPU. The rule of thumb I always like to give is if you're less than 8 CPUs, use half the number of CPUs that are available to your server. So most typically I'd set this to 4 is most common. In the one other exception to this rule, and SharePoint is the exception to a lot of rules in SQL Server, the SharePoint team likes to do things their own way. Their databases have a lot of special requirements. And you can find Microsoft has some white papers on this in case you need it. But for SharePoint, the max degree of parallelism is 1 that's required. Changing model file sizes. So if you're not familiar with this, the model database is a system database. And every time a new database gets built in SQL Server, so when you say create database through the GUI, it's built off of the model database's properties. In the initial size and the auto growth factor of model are initially 4 megabyte, and it grows by 1 megabyte unlimited. So that's not really a good model. This is one where I can't really give you a rule of thumb. There is no right number on how big your database should be initially. What I would say is, do your best to work with your application team to get some idea of how big your database is going to be. You don't want to really be growing your data files all the time. And we'll talk a little bit more. There's some other things we can help with that. But when you grow a data file, by default, SQL Server is going to zero out all that space on disk, and it's going to be a very slow operation. Typically, I like to start at 512 meg or a gig for just unknown databases, but like I say, it really, really depends, and it's something you need to kind of work with your application teams to try to get some understanding about how big the database. One of the other things is that you'll notice the transaction log by default grows in a percentage fashion. Well, this isn't too bad at first. The initial size is 1 meg here. We're growing by 10%. If you're rapidly growing, and you're rapidly growing your transaction log, which I hope you're not, that can balloon because you're going to continue growing by a percentage as opposed to a fixed amount. So that's something else you want to consider. Another thing you should consider is maybe limiting the growth of your databases. And this is really kind of an it depends thing. So the default is that the database is going to auto grow by 1 meg unlimited. I definitely change that, but perhaps you want to say it's going to grow by 512 megabytes. But you may only want to limit that to some percentage of your file system. It's kind of a matter of if you want your server to crash or a SQL Server to crash first in the event of your disk filling up. The true key here is to monitor your file growth and have a good understanding of what it is. And our goal is to maintain good growth and avoid file system fragmentation. And I have one question here that I'm going to grab. For MaxDOP settings, are these recommendations based on physical CPUs or cores? Cores, generally speaking. And I have another question about simple recovery mode that we're going to answer on the next slide. By default, models in full recovery mode. Typically, I set it to simple. If a database needs to be in full recovery mode, I set it manually. And so for those of you who don't know, full recovery mode lets us do point-in-time recovery. So the transaction log is recording all transactions as opposed to being in simple where it's not recording everything and storing it. The big key to this is if your databases need to be in full recovery mode, be sure to set up transaction log backups. This is one I see all the time, and I think a lot of it's because model defaults to full. I'll go in and do a health check on a client's database server, and there'll be all these databases in full recovery mode, and they've never had a log backup taken. So the log files are even bigger than the data files, and I think that question just showed up. Is it a problem if log file grows bigger than a data file? Yes, generally speaking. It means you're probably not doing your log backups frequently enough. We are taking transaction log backups. Yeah, so it's just something to consider. Your transaction log backup, your transaction log frequency is going to depend on your how badly you need to recover. So I've been in organizations where we've taken them as frequently as 15 minutes. So another default thing. By default, TempDB comes with one data file. For those of you who aren't too intimately familiar with TempDB, TempDB has a lot of purposes. It's not just temporary tables. Like I mentioned, Windows pages. If SQL Server's query optimizer doesn't feel like it has enough memory, it will use TempDB as a workspace area. And additionally, sorts and lots of other internal database activities take place in TempDB. So I've heard people reference it as the public restroom of SQL Server because everybody goes there. One of the things that can happen with TempDB is that if you only have one file, it's not so much a hard drive contention thing, but a page allocation contention thing. So pages getting allocated out of memory. Pages getting allocated out of memory and therefore leading to waste. So the best practice, and this is from Bob Ward, if the number of logical processors, so that's cores or sockets, is less than 8, then the number of TempDB files equals the number of CPUs, but start with 4. And if logical processors is greater than 8, then start with the number of TempDB files being 8. All of these files should be the same size. This is pretty important. And have the same autogrowth settings, because if they don't, they can grow unevenly, and you'll get hotspots. And there's 2 trace flags here that you should consider using, and you can enable those by using dbcc trace on. And 1117 is we'll do uniform file allocation. The one caveat to uniform file allocation is it will allocate autogrowth on all your files uniformly across all databases. And then 1118 is a TempDB trace flag that helps page allocation. I'd recommend using that everywhere. There's no downside to that. And I had a couple of questions about what's the right size for TempDB and what's the right size, what about the log file? So TempDB doesn't really log anything, so generally you don't have to worry about that. It's got a completely different logging model than any of the other databases in SQL Server. But in terms of sizing, it's really a play-it-by-ear thing. I generally allocate 4 to 8 1 gig files, depending on the server. But it's something, once again, you kind of have to monitor to see what your workload. The question is, should 4 TempDB files be on separate drives? And should you file and separate the log files? Because of the TempDB log mechanism, you don't necessarily need to separate those files. Actually, I didn't. It was something I did, and we'll talk a little bit about standards later, but it was something I put in as standard at my last company, was that we wouldn't separate it because it really wasn't worth having another drive. And no, those 4 files don't need to be on separate drives. unless you're experiencing really bad I/O performance. So creating SQL agent alerts for critical errors. The main errors here that we're talking about are 823 through 825. And 823 and 825 are disk corruption errors, and then severity 16 through 25 resource errors in SQL Server. These are really huge because you're going to know about things that are bad things that are happening on your server before they happen to others. This is pretty important. You can tie alerts to actions and/or pages. So using the SQL agent and configuring DB mail, you can be notified about this, any error that happens on your SQL Server way ahead of your users. And it's something else to think about is that you need to set up DB mail, and hopefully you have an SMTP server in range so you can mail things from your SQL Server. I was asked if I have a checklist of these items that I follow, and yes. And that'll be downloadable after the fact, and that's what's going on the install we started right now. And another question about DB mail and performance or security. I've never had it be a concern, definitely from a performance perspective, unless you're just overwhelming it. And then from a security perspective, I'd have to leave that for another answer. I've used it almost everywhere I've been, but I didn't know about any security holes off the top of my head. Cost threshold for parallelism. So this kind of ties back to we were talking about max degree of parallelism earlier. The default setting in SQL Server is 5, which is generally too low for anything except a pure OLTP environment. This one, of everything we're talking about, is probably the most it depends setting, and I hate to use it depends because I know it's, as a consultant, I use it way too much. But this really does depend on your workload. So this is the cost of a query where the optimizer is going to decide whether or not to take it parallel or take it single-threaded. The best guideline I've read is to start with 50 for this cost and move from there. Parallelism is really odd, and if you really want to geek out and read Paul White's blog, Paul White blogs at sqlblog.com. He can tell you a lot about the internals of how parallelism works. Parallelism can be interesting. I've had queries that have run way faster in single-threaded mode than they did in parallel, and it's just hard to explain. But this is definitely something I consider a best practice. Backup compression. This is probably, of everything, this is probably the biggest no-brainer of anything that we're talking about. It costs a little bit of CPU, but your backup and restores will greatly benefit from this. I tested out pretty extensively a backup appliance at one of my last employers, and the company that produced the backup appliance had deduplication on it. So with deduplication, you tend not to get as good of deduplication rates when you're working with compressed files, so they didn't want us to send compressed backups. It was taking, on a terabyte database server, it was taking nearly 2 to 3 times as long for us to do backups with no compression on. So the way backup compression works is your backups are compressed streaming. So even though the SQL Server estimates the full size of the backup and then compresses it, it's compressed in line. So there's no, you're never backing up the whole full size of the database. So it's always smaller. And when you restore that, you're restoring the small size of the database. So it's pretty much a win-win. The only way I'd ever recommend not running this is if you're just under constant CPU pressure and you can't afford to give up any CPU cycles. But it's definitely something I think about using all the time. And the other big benefit from this, it was introduced in SQL Server 2008 natively. There were a number of third-party tools that had done it in the past. But in SQL Server 2008 R2 forward, backup compression is included in Standard Edition, which isn't always common for new features. I had one question about max degree of parallelism. Start with 50 and move from there. In what increments? 1, 5. Probably 5 is safe. And there was another question. These errors are something SCOM will warn about probably as well. I'm not 100% sure on that. I haven't used it in a while. I prefer to monitor myself. And another question about backup compression: does transparent data encryption negate the use of backup compression? You'll get lower compression rates with transparent data encryption, but you'll still get some compression, so there is definitely some benefit to using it. And then one last question that I'll answer right now is, how safe to use is trace flag 1117? It's not unsafe. The only thing I'll say about it is it means all of your data files are going to grow at the same rate at the same time. So if one data file grows, you're gonna run into that. They're all gonna grow at the same time. So that's a little bit of a challenge. It's something kind of to think about. It's not too overly complicated. So next we're going to talk about a Windows permission. We talked a little bit about file growth earlier, and how by default SQL Server will zero out a data file on growth, which this means if you're growing a data file, 4 gig, the process is going to write zeros to all 4 gig it needs to allocate before you can even see it. What you can do, and this does involve a Windows Server reboot, but either via AD or locally on the server, but do this via AD, it's the best practice, is to grant a Windows permission, and it's right here. Let's zoom in a little bit. This is a Windows permission in group policy management, so in most environments it's something you'll have to ask your Active Directory administrator for. But you want whatever accounts were running your SQL servers to be able to perform volume maintenance tasks. What that means is SQL Server uses a different process for allocating the file, and it doesn't zero out the full file. Pretty safe, no-brainer. Zero out like initialization was a question I got. No, so zero out, it means it's writing zeros to the full file. With instant file initialization, the file is just grown. It's not zeroed out fully, so the task happens a lot faster. Excuse me. So the remote dedicated administrator connection. By default, there's something known as the dedicated administrator connection in SQL Server. And what this does is provides a little bit of dedicated CPU, memory, and scheduler tasks to a admin account. However, by default, it's not configured to allow remote connection. So you can only run that connection as if you're physically on the box, either via RDP or in front of the server. And even then, you're working with the server that's completely pegged out. So trying to do that's going to be a real challenge. So this is something else I configure on build, is configuring remote admin connections and allowing this to be open. And it's a pretty straightforward command, and this lets you use, and the way you connect to this connection is using admin. You need to connect in SQL CMD mode and using admin : the server name. Maintenance plans. The maintenance plans in SQL Server that are built in aren't bad, they just aren't that good. There's not a lot of intelligence to them. For example, there's no way to tell SQL Server, how out of date stats are before you tell it to go out and gather new stats. Or setting a threshold for an index rebuild versus reorg. There's a solution called Ola Hallengren's SQL Server Maintenance Solution. Ola Hallengren's the SQL Server MVP from somewhere in Scandinavia that I'm forgetting off the top of my head right now. But this product is a gold mine. Almost all of my friends in the SQL community recommend this to their clients. And what this handles is CheckDB, index maintenance, statistics, and backup. So CheckDB, for those of you who don't know, is a really important process that you should run on a regular basis, maybe not every night, but perhaps weekly, to check the integrity of your database. That can be its own whole presentation, but it's something you should be running on a regular basis. And Ola's from Sweden. Thanks for whoever said that. Index maintenance. So SQL Server indexes tend to get fragmented when we do a lot of inserts and updates. So what index rebuilds do is allow us to reorganize those indexes so we have less, they just function better because we're not scanning all over the disk. They're in one place. Statistics get out of date. Our data changes from time to time, and our statistics on SQL Server don't keep up with that. There is auto-gather statistics in SQL Server. However, that requires a 20% of the rows to have changed in a table for the auto update stats to happen. And then lastly, backups. OLA has backups built into the solution. There's some more intelligence built into it. For example, if you're using always-on availability groups in SQL 2012 or 2014, he's got intelligence built in there. It's just a really wonderful solution. SQL maintenance plans aren't terrible, and in a nutshell, they'll work in a hurry. The one caveat I'll warn you is never, ever, ever, ever use ShrinkDB. There's an option in maintenance plans to shrink your databases. What they should really call ShrinkDB is auto-fragment. It will fragment the crap out of your databases. The one thing you may ever use, you may shrink stuff with, is maybe shrink a transaction log file that grew too big, and you didn't need it to be that big, but never ever use shrink database. The other thing to think about, yes, Karen. The other thing to think about is patch SQL Server. So find out the current service pack and cumulative update level for SQL Server for the version you're using. SQL Server builds.blogspot.com is what I always reference. And patch your server. There's no time like the install time to get on the latest release. If you're using SQL Server 2012 and up, and I hope you are, there's a parameter called update source. You can point this parameter to Windows Update or a local UNC source or a local path. And I think potentially you can point this to System Center Configuration Manager, but I haven't done it. So what this does, it will go out and get the latest patch sets for the version of SQL Server you're installing. So if you're installing SQL Server 2012 Service Pack 1, it will go out and get all the latest cumulative updates for that package. Patching is kind of a whole different cycle. It's something you need to think about and build into your infrastructure planning. We try to do it on a regular basis just to keep everything up to date. It used to be that there wasn't much new functionality added in some of the cumulative updates, but I know just recently one of the things in SQL Server 2012 Service Pack 1 Cumulative Update 2 allowed you to back up directly to Azure, which is kind of a neat new feature. And in SQL Server 2012 SP1 CU8 also allowed you to use Power View against a multi-dimensional cube, whereas you couldn't do that before. So keeping things up to date now means a lot of new features. As Microsoft grows more agile with this development process, it becomes more and more important to keep up to date on this. A little bit about the cloud. All of the above stuff I mentioned applies to Azure VMs. It pains me to say this, and I really wish Microsoft would fix this, but if you build one of the Azure VMs with the SQL Server image on them, it is a next install. Nothing has been changed. So one of the things you can do, and we'll talk a little bit more about it when we get to the private cloud piece, is you can build your own image. So you can have your own image of SQL Server that you can deploy to Azure. And it could be configured with best practices. And we're going to change subjects a little bit, so I'll answer a couple of questions. Then what to do in place of ShrinkDB on data files. If your data files get big and out of sync, that's the only time you should ever do ShrinkDB. I'll give you a caveat for that, but then you should rebuild all your indexes because everything's going to be fragmented. But the right answer is not to try to avoid it at all costs. A question I got was regarding updating statistics. If I have a partition table, is that 20% for each partition or across the table? Before 2014, it's across the table. In 2014, I believe it's across each partition. And I had a question on any difference between physical and virtual server for performance. That's a whole other topic. We'll talk a little bit about VMs, but performance-wise, that's kind of a different talk. So I always like to say standards are important. And I like this picture. This isn't illegal drugs. It's something I got from a chemistry lab. But having standards and having a really consistent way of doing things is really important. Actually, it's kind of funny that this picture is from a lab. I also have a lot of background in the pharmaceutical industry. In the pharmaceutical industry in the U.S. and Europe particularly, we're under very heavy regulation from the U.S. Food and Drug Administration and the EU Drug Administration. So we had to document everything we did, and it was painful. You know, it really was painful doing 10 pages of paperwork to apply a patch to a database server. But at the same time, you got really good at writing standard procedures, and you realized how important they were because you had a lot more consistent process for building servers. Having written build standards is really important, and this is where you want to define everything. Your drive locations. One thing I'll recommend here, too, is an option that started in a couple of versions of Windows Server ago, is consider using mount points for your database servers. It's something I definitely recommend than using clusters, if you're using clusters. But what a mount point is it lets you, for example, if D is going to be the drive you're installing SQL Server to, you could have D/data, D/TempDB, D/transaction log, and they could all be individual devices as opposed to being D, E, F, and G. It's a little cleaner and it becomes easier to manage. You also, depending on and some of this is going to depend on the size of your environment, right? If you're only going to have 20 servers, you can be a little more flexible. At the large enterprise I was at, we had standard volume sizes. So by default, a standard data volume was 100 gig. If you needed more than that, you could request it, but you had to have a standard. So like 25 gig was TempDB. Depending on what your storage environment looks like, you may want to configure, work with your storage team to define the types of ones that get allocated to your server. This varies with solid state and spinning disk, and it's something you just need to think about. Additions, settings, and builds. So like we talked about, some of the settings in SQL Server, are dependent on the nature of your environment. So those kind of things you want to think about. Having a standard build, so saying everything from now on is going to be on SQL 2012 or even 2014. Definitely something to think about. OS, and this is something you probably want to work with your Windows team on. I worked hand in hand with our Active Directory folks on my architecture team, and we were able to configure the best things for SQL Server and Windows. One example of this, and it ties into security here, is the accounts that manage SQL Server. In a public company, you're typically using process accounts, but also your auditors typically want you to change the passwords on those accounts all the time, which can become really painful in a large SQL Server environment. Well, starting with Windows 2012, there's a feature called Group Managed Service Accounts. And a Group Managed Service Account is exactly that. It's managed. So you never have to set the password. Active Directory maintains it, and you allocate permissions to servers to use it. And starting with SQL 2012, SQL Server could use that. So that was an example of a feature I learned about from working with my Windows team to better implement my SQL servers. High availability and disaster recovery options. This is also something to think about. Whether or not what you're going to use for high availability and DR. Clustering, virtualization, DR if you're using log shipping or mirroring or availability groups, all things to think about in writing an enterprise standard for a document. And you're going to want to revisit these standards at least every 6 months because things change pretty fast. I mean, look, we just got a new version of SQL Server today. And the revisions don't take that much time. It's definitely writing the standards that's the challenge. One thing I'll say about standards is having standard hardware is good and can really help. At my last role, I had the advantage of knowing that SQL Server was only ever going to get installed on 2 types of physical servers, and that made life a whole lot easier. I realize not everybody has that that option, but it's something to think about. And work with your sysadmin teams, like I mentioned, for guidance on the OS level. Let me take a couple of questions real quick. If TempDB has grown too much, can we shrink TempDB without restarting the server? Don't ever shrink TempDB. You can corrupt your SQL Server instance. Can you repeat why is it not recommendable to shrink database? Basically, it's going to fragment all your indexes. And Bill Bergen, or if you're the Bill Bergen I used to work with at Wyeth, answer another question. But my understanding is with mount points, you need to back up the registry in order to avoid the problem of failover with that definition of mount point. And he is not. I'll take that question offline. I'll have you can email me. My email will be in the end. So exceptions. There are going to be exceptions to your standards. I know, shocking, right? This is something that happens, and it's not a big deal. It's something I definitely learned to deal with in building the private cloud. You kind of have to take an 80-20 approach to everything. You have to think about what's going to work for 80% of your environment, and that last 20%, you can work with them to meet their needs. Those typically are the fun cases anyway, because you're pushing the envelope of what you want to do. I know our customer-facing web server, or web SQL server, at my last employer was really a challenge, and we had to use special hardware for it. It just needed the capacity. So don't sweat exceptions, but don't let exceptions get you out of the way of having a good standards process. I think it's one of the most important things to maintaining a solid enterprise. Plus SharePoint, which is the 1% of databases. So process automation. Let's talk about this. I mentioned earlier, clicking next doesn't add a lot of value to SQL Server. One of the things we did was mainly completely automate our process. We occasionally had people have to kick off a script or something, but we simplified things and we automated the build process. Actually, as we're speaking, my build is going on in the background, so when I'm done with the slides in a few minutes, we'll take a look at that SQL Server that we were building. Nobody likes to talk about plumbing, but man, the world would be a terrible place without it. Having your own infrastructure server is optional. It's definitely something I'd recommend in any given architecture, but it's incredibly handy. And what an infrastructure server is, it's a place to store your installation files. You can use it as your update source for your SQL Server installs too, going forward with 2012. And what we used it for was as a metadata and monitoring hub for our environment. So every new server registered itself with the infrastructure server. So we automatically, as part of our build process, had a list of servers that were part of our environment. We generally knew who the owner was. We knew the app name, so that was very handy, and we could monitor that, so we'd know if we had new servers on our network or new servers in our environment before anyone else did. We also used it as a monitoring hub, so we pulled back a lot of information from our servers in the field back to the infrastructure server, so we could do a great deal of performance analysis there. It was very handy. The one caveat I'll give you is it should be very secured. You have a lot of confidential information there. So it's something you just want to make sure you have it pretty well locked down to everyone, just the DBA team can get to it, no other real logins, and apply all your security patches. And it's something that can definitely be a VM. It doesn't have to be the biggest server in your environment. Script your installs. I don't recommend installing the GUI, using the GUI. You can automate for consistency and speed. You should still QA, because this process is dependent on having things like standard disk letters. And one example I'll give you today, as I was preparing for this demo, I did a SQL Server install. And I did it silently, and the install worked fine, but I went to apply all the best practices we've been talking about. And SQL CMD, which is the command line interface to Microsoft SQL Server, is in the different place in SQL Server 2012. So it was in a different location, and I couldn't. my script wouldn't run. So I had to edit that. So it's definitely something you should QA these on a regular basis, make sure your processes work when releases change and things like that. But one of the things I'll share with Steve, and it'll get posted to the site, is this batch file and this INI file to install SQL Server. And you can take a look through it. So virtual machines. This can get a little more complicated. You can build your virtual machines the same way you build your physicals. That's fine. It tends to be a little messier. Installing SQL Server at build time, as long as your drive letters map to your physical machines and you're on the same standard, that's fine. But that takes a while. You still having to install SQL Server. What I did, and we'll talk a little bit more about it in the private cloud section of this talk, was I cloned a VM that had everything we needed, and I made the changes to it at runtime. So basically, we renamed the VM, we changed the few places we had to change the name of the server inside of SQL Server, and then we just applied our best practices, registered it with our infrastructure server, and it definitely gives you a much greater ability to do automation. It's a lot easier to automate with virtual machines than it is physical. You'll have a lot of options. You may want to use some different settings for your virtual machines than you would with physicals. Always trust but verify. So even though you're doing this great process, you still want to verify everything. That infrastructure server I was talking about, you may want to query or do a health check on all of your servers every day. Management loves this sort of thing. So what I did, I used my infrastructure server and I used reporting services. And I had a script that ran against every server every day. It came back and gave me the results. I could show trends on things that were out of compliance. I could send it to the DBA team so they could fix it. It's definitely something worth doing. If you're in a smaller environment, something like policy-based management can work really well for this, or even central management server, which is also built into SQL Server. When you get to a large scale, those things are a little bit more difficult to manage. Let me take a couple of questions real quick. How about creating a SQL Server installation, ISO installation as part of the automation? That's definitely an option. One of the things I do is I leverage my infrastructure servers. I had the ISOs extracted there. So that was where they lived. That's about it for now. So building a private cloud, and yes, this is a picture of the Holy Grail. This was really cool. So this was something we did. We basically built our own version of Windows Azure. We had all sorts of environments. We had Linux VMs. We had SQL Server VMs, plain Windows VMs. Our users came in through a user interface, and 6 minutes later they had a VM. It was pretty nifty. Some issues, though. You have to make decisions for 80% of your environment. We talked a little bit about this above. You're going to have users who are going to request, VMs that have half a terabyte of memory. That's really not going to work well in a virtual machine environment, especially a large-scale virtual machine environment. So you really have to address that. And you just have to say, no, sorry, if your needs are that special, you probably need your own physical box. The most challenging parts of doing this weren't building the SQL Server install. That, in all honesty, is not that different than what I set up today. Windows is a little bit trickier. When you're creating new machines, joining them to the domain, naming them is a little bit more of an issue. So things like that were a little bit of a challenge. We also had some challenges in and around DNS. So, for example, using DNS was a little bit of a challenge because we had to register with DNS, and we weren't using Active Directory for DNS. We were using a different DNS, so there was some delay there. So that was a challenge. But by far, the biggest challenges we had were more management and sprawl than technical ones. We had users requesting SQL Server VMs that were outside of the scope of the management of the DBA team. And so we just kind of had to make it clear that they could request that, and we were fine with that, but then they had to manage their own VM, which they were generally okay with because these were a lot of, in that case, would be development type VMs, and it was just app teams that wanted to have a VM very quickly. So here's how our architecture for that worked. We had a user interface, which was through our intranet site. We have a service management layer, and this is really the magic if you want to have a private cloud, and this is a whole different talk, but you can use System Center for this, and there are others. We used a third-party solution called PMG, and what that does is interface to your back-end infrastructure. So in this case, the user would come in and request a VM, which would be a SQL Server VM. They'd go to the service management layer, and the service management layer would in turn generate scripts that would go out to VMware, which was our back-end infrastructure, call a series of scripts to build the VM, and then lastly, our PowerShell and SQL scripts would get executed to customize our VM for a SQL Server. And our lessons learned from that were always capture your owner information. If you're building a private cloud, you're going to have to realize that all servers may not be managed to the same level they would be in a regular environment. And as painful as this is for DBAs, and I know because I've been one most of my professional career, you have to release a little bit of control. So let's go out to our server and see what happened. Okay, PowerShell's here. Oh, and we got an error because I forgot to delete the data files. I'm sorry about that. Always do proper cleanup. Okay, so we failed, but we'll use this example to show you a couple of things. SQL Server is going to go, by default, go to program files. And if we go, in this case, 120, and set up Bootstrap, this is where the installation log file is going to be. And we can always just go to summary.txt. We'll open this with Notepad. And at the top here, we see failed, and we can see the details below. And if I scroll down, I see my failure happen because TempDB already exists. What happened was I did this morning, and I uninstalled SQL Server, but I forgot to check to see if the data files were still there, and they were, so the install failed. But let's walk through our components for that. So the first thing we have is this batch file that we're going to call. Bump up the font a little bit for you guys. So here we're calling dsetup.exe, so this is SQL Server, and then we're just passing in this configuration file, Win 2008 standalone 64-bit configuration file.ini. So that's going to run our install process. So we'll take a look at that ini file in a second. Next, we're going to say we're calling SQL CMD. So this is our command line interface to to SQL Server, and we're going to run this file SQL best practices run once.sql. And so let's take a look at our configuration file. And we're going to specify a few things here. So this is where we're going to specify our update source for SQL Server updates, all of our install directories, our TempDB directory. Here, since this is a standalone VM, I'm just putting everything in data, but you'd probably want to put it in its own volume. Same thing with log files. We have default directories for the user DBs as well as the system DBs, as well as the backup DBs. Here you put in the SA password. One of the things I like to do is use a big, long SA password and then disable the account. Because if you set up your Active Directory groups right, you shouldn't have to do this. You shouldn't have to log in as SA ever. Here's where I set my passwords for all my services. This is where I define my list of features. I have this commented at, but I also have the list of features for Windows Server Core, which is the GUI-less version of Windows. We have our action, this is install. Indicate progress false, and then setup we have quiet equals true so that we won't have to watch the installation process. Here we're defining our agent account name, our instance name, and and we're not installing analysis services. I was installing reporting services. And I gave this is another key one to configure. You want to make sure you give your DBA group Windows accounts to be system administrators so you can actually log into the server. And here we're setting SQL, so mixed mode authentication. And then lastly, we'll check our bash script, or our SQL script rather. And so we're going to do a lot of things here. We're going to pretty much do everything we talked about. We're going to set trace flags for TempDB allocation. One other trace flag I like to set that I forgot to mention is 3226. What that does is suppresses transaction log entries for backing up transaction log entries. So we won't see backup log success in the log, mainly because it just overpopulates the log. We're setting model to recover simple. We're changing the file growth. And we're also changing the file growth for MSDB and master here. Here's some code to dynamically configure your TempDB files based on the number of CPUs. That's pretty handy. Additionally, here we're going to configure max server memory based on a percentage of overall physical memory. So we're grabbing that from a system table. We're also going to set MaxDOP based on CPU count. Enable remote admin connections, enable backup compression, change cost threshold for parallelism, implement database mail. These are all the things we talked about. Implementing our alerts. So we're setting up our alerts, and we have that configured to go to the DBA team, which we configured above. These are configuring all the agent jobs for those alerts. And then lastly, I set up OLA's maintenance solution. Sadly, our server is gone because we blew it away. But so typically, had this run correctly, everything would be built, and we'd have a server ready to go. And I lost my screen. I'll be right back.
While you're getting the screen back, Joe, I just wanted to let you know we're getting close to noon. So.
Yeah, no, I'm good on time. So in summary, do this stuff. Make your servers great. Automate and repeat, and your servers will love you. You want to do this on a consistent basis. I'll put the scripts and stuff on my blog, and I'll share the slides with Steve on the site. The video will be up too if you have any questions. Let me just see if we have any more questions.
I'll send you a script of the questions, and if you think you've missed anybody, we'll get in touch with them.
Yeah.
Or I'll let you get in touch with them.
So I have a question here. What is a private cloud, and what are the benefits? Typically, a private cloud is a dedicated virtualization environment, possibly for SQL Server or just a dedicated virtualization environment in a company that gives you rapid VMs so that you can quickly meet users' needs. So in our case, it was self-service. It was what we were going for, and just faster. And here I just asked a question about volumes and SANs. Can you be assured account SIDs will be using the same? I'm not clear on this. Slides will definitely be available. Like I said, I'll have them on my blog. Let me see if I missed anything else. Have you read what the best practice for that the best practice for security is to use local Windows accounts for process? How would these work with AD managed group service accounts? Assuming it would not. So managed service accounts, in some ways, are more secure. You could potentially give each server its own managed service account. I wouldn't necessarily want to do that in a large environment, but in a smaller environment, to me, that would be the most secure way of doing it, because ADs actually manage everything. Ooh, this is a tough question. Regarding TempDB, what is the least intrusive way to release space from the TempDB database when the drive is full and TempDB cannot grow anymore? You're in trouble. It's really only to reboot, probably, or restart SQL. I think possibly in a SQL single user mode, resize the TempDB data files, and then restart SQL full. Really, it's allocate more space to TempDB somehow. That might be a nice use case for the feature of having a data file in Azure. Maintenance plans are easy to create. Why aren't they good? They just don't give us the same level of flexibility that OLA scripts do. I think it's probably a little bit better. Maintenance plans are a little, I don't want to call them dumb, but they're pretty basic in terms of the intelligence that's built into them. And I think that's it. Oh, how to maintain log file in simple recovery mode. Take full backups of your database on a regular basis, and that will keep the log file from growing. And there's no way to release that space from TempDB if you don't want to start SQL Server. Okay, well, thanks, everyone. And I hope you had a good time, and I did as well.
Well, thanks, Joey. That's awesome. We had more questions than any presentation we've had, so that shows interest in this topic. We hope to have you back again sometime. So
definitely.
As you stated several times, should have this session and PowerPoint up on our site within a week, and your stuff should be available probably pretty quickly. So if you need anything, Joey's got it on his blog. We actually had a tie for the Amazon gift card. This is the first time we've had that. Jeremy Kamani and Sandra Delaney. So we'll be getting in touch with you and letting you know how to get your $25 Amazon gift card. And we have another session coming up next month, May 6th, SQL Server Internals Party, when I send out the notification that all of our the recorded session is up and live. I'll send out an invitation to that. We appreciate it. See you next month.